Hello everyone, I'm Danica Janolino. I'm gonna talk about the preparation of culture units or ponds. First, I will explain to you what is a pond culture. So a pond culture is a popular aquaculture production method with many aquatic species cultured in ponds. To have a successful pond production, ponds must be properly sited and built with careful assessment of water availability, quantity, and quality. Where aquatic organisms are raised in natural or artificial ponds, this involves the draining and drying, filling and cultivating, leveling the pond bottom, and the soil sampling. First, I'm gonna talk about the draining and drying. So, dry the pond for about 3 to 5 days until the bottom soil hardens and cracks. The purpose of drying is to eradicate pests, predators, and competitors, to eliminate obnoxious gases resulting from organic matter decomposition, and lastly, to kill disease-causing microorganisms. The second method is the tilling and cultivating the pond bottom. This is done with the use of either rotivator, plow, or rake. Purpose of tilling and cultivating is to make the subsurface nutrients available at the surface of growth for natural fish food, to eradicate the burrowing fish enemies, and lastly, to eliminate and destroy the pond weeds. The third method is the leveling the pond bottom. This is done to make the pond bottom surface level and sloping toward the gate for ease and draining and drying. The next method is the soil sampling. This shall be undertaken to determine the physiochemical conditions of the different pond compartments, particularly on the organic matter content, nutrient contents, pH, and many others. So this is necessary to identify the actions and solutions to take in conditioning and treating the soil before the pond will be used for fish culture purposes. What is lime? A lime is a material or substance derived from limestones and shells, like oyster shells, which contain mainly of calcium carbonates. There are 4 kinds of limes used for treating or conditioning the pond soil and water. First is the pulverized limestone, which is the calcium carbonate. Second is the burn limestone, which is the calcium oxide. Third is the hydrated lime, which is the calcium hydroxide. Lastly is the dolomite lime, which is the calcium magnesium carbonate. In the agricultural lime, dolomite lime are prepared by crushing limestones to particle sizes to 10 mesh to 60 mesh with rock crusher. Next is the burn limestone. It is prepared by heating limestone in a furnace or a very high degree of temperature between 500 degrees to 600 degrees Celsius. In the hydrated lime, it is prepared by treating burn lime with water. So how to distinguish one lime from other limes? This is done by examining or analyzing the pH or a slow rate of 10 to 20 parts distilled water and 1 part liming material. So the pH of agricultural lime will not be more than pH 10.
In order for us to compute for the quantity of lime. So the QL here is the quantity of required lime, the DPH is the desired pH, the APH is the actual average pH reading of the pond soil, the NVL is the neutralizing value of the lime, and the A stands for the area of the pond in hectare. So the desired pH must be subtracted to the actual average pH reading of the pond soil, and that is multiplied to 0.5 ton per hectare and multiplied to the area of the pond in hectare. And that will be divided in the product of 0.1 multiplied to the neutralizing value of lime. So here is an example of getting the quantity of lime. The desired pH is 6.8 minus to the actual average pH acquired upon reading the pond soil, which is 6.5, and that will be multiplied to the 1 hectare, which is the area of the pond. So 0.1 is constant here, and then multiplied to the neutralizing value of lime, which is 1. So the final quantity of lime to be used is 1.5 tons agricultural lime. So in the second example, you may follow the same process, but you must note that the neutralizing value for the quick lime is 1.73, while for the hydrated lime is 1.35. So in this table, we have the amount of lime to be used with the following pH ranges as recommended. So when the pH is less than 5, the amount of agricultural lime in kilogram per hectare that we must use is 3,000. For the hydrated lime, it's 2,205, and for the quick lime, the amount is 1,676 kg per hectare. So in the third and fourth row, these are the amount of lime to be used when the pH ranges 5 to 6, then 6 to 7. We must remember that the sandy soils with the pH ranging 6.1 to 6.5 may not be treated with lime, and the decision on what kind of lime to be used must be strictly considered. In addition, aside from neutralizing acidity, applying lime should foster greater rates of organic matter decomposition. So we must remember that the quick lime and hydrated lime have a very high calcium carbonate efficiency that may kill microbial organism, and the decomposition may be stopped. So considering those facts, agricultural lime is considered as the best lime for the decomposition of organic matter. So in order for us to neutralize the acidity, we apply lime in the pond's bottom surfaces and on tops and sidings of pond dikes. After this procedure, the liming, our pond is ready for fertilization. The next topic is fertilization and fertilizers. So by its definition, fertilization refers to the addition of organic and or inorganic fertilizers to soil or water to stimulate and maintain growth of desirable phytoplanktons and other kinds of algae for food of animal organisms including the fish. While the term fertilizer refers to the organic and or inorganic fertilizers. The general classes of fertilizers are the organic fertilizers and the inorganic fertilizers. The fertilizers that are capable to decompose and which contain varying amounts of nutrients are called the organic fertilizers. So the examples of organic fertilizers are the animal manures, dung, or droppings. We also have the green manures and the compost plant and animal materials. So for the fertilizers that are not decomposed but rather dissolved in water and which contain concentrated amounts of at least one of the three major plant nutrients or the nitrogen, phosphorus, and potassium are called the inorganic fertilizers. This kind of fertilizer can be classified as single element, incomplete, and complete. To those fertilizer that contain only one fertilizer element is called the single element fertilizer. To those which contain two fertilizer elements are called the incomplete fertilizers, while the complete fertilizers contain all the three major nutrients, the nitrogen, phosphorus, and potassium. So in order for us to determine the available amounts of nutrients present in a given inorganic fertilizer, we may use this formula. Weight of nutrients is equal to the weight of fertilizer, and that will be multiplied to the percent of fertilizer nutrient available for use.
Good day everyone, I am Chloe Feyne Hierro, and this is a continuation on how to determine the available amounts of nutrients present in a given inorganic fertilizers. So for the first example, we have 50 kilograms of urea containing 46% of nitrogen. In order to get the weight of the nutrient available, you substitute those values to the formula. You will have 0.46 times 50 kilograms equals 23 kilograms of nitrogen. Now for the filler, you just subtract 23 kilograms of nitrogen from the weight of the fertilizer, which is 50, then you will get 27 kilograms of filler. For example number 2, we have an incomplete fertilizer, which is 50 kilograms of ammonium phosphate containing 16% nitrogen and 20% phosphorus. Multiply 50 kilograms by 0.16 equals 8 kg of nitrogen. To get the weight of phosphorus, 50 kilograms multiplied by 0.20 is equal to 10 per kilogram phosphorus. To get the total weight of the nutrients, we add 8 kg of nitrogen plus 10 kg of phosphorus is equal to 18 kg of nitrogen and phosphorus. Now for the filler, the total weight of nutrient available is subtracted to 50 kilograms of fertilizer. This is equals to 32 kilogram filler. Third example, we have 50 kilograms containing 14% nitrogen, 14% phosphorus, and 14% potassium. Now for the weight of the nitrogen, we multiply 50 kilograms by 0.14 equals 7 kilograms. For phosphorus, we have 50 kilograms times 0.14 equals 7 kilograms. And for potassium, 50 kilograms times 0.14 is equal to 7 kilograms. For the total weight of the nutrients, we add all three, equal to 21 kilograms NPK. And for the filler, 50 kilograms minus the nutrient available, which is 21 kilograms, is equal to 29 kilogram filler. Moving on to the next part, how to determine the required amounts of inorganic fertilizers with a given recommended or required treatment or dosage. We have two formulas in order to get the amount of fertilizer in a bag or in kilograms. So option 1, amounts of fertilizer in kilograms is equal to the recommended treatment or dosage of nutrient in kilograms divided by the percent of fertilizer nutrient available for use in decimal. For option 2, amounts of fertilizers in bag, we have dosage of nutrient in kilogram times 100 divided by the weight of the fertilizer per bag times the percent of fertilizer nutrient available. For example number 1, we have the recommended dosage, which is 40 kilograms, and the available fertilizer, which is urea with 46% of nitrogen. For option 1, amounts of fertilizers in kilogram, we have 40 kilogram of nitrogen divided by 0.46 nitrogen in urea equals 86.96 kilogram urea. For option 2, amounts of fertilizer in a bag, we have 40 kilogram nitrogen times 100 divided by 50 kilogram per bag. Suppose that each bag weighs 50 kilogram times 46 nitrogen in urea equals 4,000 divided by 2,300, which is equivalent to 1.74 bags urea or 86.96 kilograms of urea. For example number 2, we have the recommended dosage, 30 kilogram nitrogen, 20 kilogram phosphorus, and available fertilizer, 46 and 1620. So first, we will use phosphorus in the recommended dosage and 1620 in the available fertilizer. So 20 kilogram of phosphorus divided by 0.20 phosphorus in 1620 equals the weight of the ammonium phosphate, which is 100 kilogram 1620. 100 kilogram times 0.16 is equal to 16 kilogram nitrogen. 100 kilogram times 0.20 phosphorus is equal to 20 kilogram phosphorus. So for letter B, subtract 16 kilogram of nitrogen from the previous equation from the recommended dosage of 30 kilogram nitrogen. So we will get 14 kilogram nitrogen divided by 0.46 nitrogen in urea. We will get 30.43 kilogram urea. As a summary, 100 kilogram plus 30.43 kilogram equals 130.43 kilogram combination of ammonium phosphate and urea. For option 2, for the amount of fertilizers in bags, we have 20 kilogram phosphorus times 100 divided by 50 kilogram per bag times 20% phosphorus in 1620. So cancel out units kilogram and phosphorus. 2,000 divided by 1,000 equals 2 bags of 1620. Now to get the weight of the fertilizer in those 2 bags, we multiply that by 50. Suppose that each bag contains 50 kilograms. So we have 100 kilogram of 1620. 100 kilogram times 0.16 nitrogen equals 16 kilogram nitrogen. 100 kilogram times 0.20 phosphorus equals 20 kilogram of phosphorus. For letter B, 30 kilogram of nitrogen minus 16 kilogram nitrogen times 100 divided by 50 kg per bag times 46% nitrogen, 1,400 divided by 2,300 is equal to 0.61 bag urea or 30.43 kilogram urea. So the original outcome of this equation is actually 0.608. If you want to convert that into kilogram, you just multiply it by 50, then you will get 30.43 kilograms urea. So for example 3, we have the recommended dosage 25, 10, 4 kilogram NPK, and 3 available fertilizers. So first, you will use the smallest number in the recommended dosage. In this case, it is 4 kilogram potassium and complete fertilizer. So 4 kilogram potassium divided by 0.14 potassium in the complete fertilizer, cancel out the units, you will get 28.57 kilogram of 14, 14, 14. Now you identify the weight of the fertilizers. Let's start with the nitrogen. 28.57 kilogram times 0.14 nitrogen equals 4 kilogram nitrogen. 28.57 kilogram times 0.14 equals 4 kilogram phosphorus. 28.57 kilogram times 0.14 potassium equals 4 kilogram potassium. So only potassium was satisfied. We still need to satisfy N and P. Now for letter B, 10 minus 4 kilogram phosphorus divided by the percent of phosphorus in the incomplete fertilizer, which is 0.20, is equal to 30 kilogram 1620. Now we look for the weight of N and P. The weight 30 kilogram times 0.16 nitrogen equals 4.8 kilogram nitrogen. And 30 kilogram times 0.20 phosphorus equals 6 kilogram phosphorus. If you add that to the previous weight of phosphorus in the complete fertilizer, you will get 10 kilogram of phosphorus. Now phosphorus is satisfied. In letter C, 25 kilogram nitrogen minus the previous weights of nitrogen, which are 4 and 4.8. If you add that, we'll get 8.8. So 25 minus 8.8 divided by the percent of nitrogen in urea, which is 4.46 nitrogen. So 16.2 divided by 0.46 equals 35.22 kilogram urea.
Good day, everyone. My name is Lovely Joyce Fulgar, and to continue the topic, the question is, what would be the amount of inorganic fertilizer to be applied in a 1 hectare fish pond if it requires 10 kilograms of phosphorus every 2 weeks? The available inorganic fertilizer is only 1620. For the formula, the amount of fertilizer is equal to the required dosage in kilograms over the percent of fertilizer nutrient available in decimal. For the solution, we have here 10 kilograms of phosphorus over 0.2 phosphorus in 1620. The total would be 50 kilograms of 1620 every 2 weeks. For the next topic, we can also use the ratio and proportion formula or cross multiplication technique. Problem number 1. The standard amount or rate of fertilizer application is 50 kilograms per hectare of 1620. How much amount of the same fertilizer is needed if the area to be fertilized is only 3,500 square meters? For the solution, we have here the number 1, the 50 kilograms over 1 hectare multiplied to x over 3,500 square meters. In order to cancel out the square meters, we will multiply it to 1 hectare over 10,000 square meters. For the number 2, we already multiplied the 3,500 times 1 hectare. Number 3 would be 3,500 over 10,000 hectares, which results to 0.35 hectares. Number 4 is the cross multiplication of 50 kilograms to 0.35 hectares. The total is 17.50 kilograms per hectare, and in order to cancel out the hectares, we will divide it into 1 hectares. Number 6 would be the total, which is 17.50 kilograms of 1620. The problem could also be solved by converting first the standard ratio per hectare to standard rate per square meter and then multiply with the problem area to be fertilized. The solution would be A. 50 kilograms per hectare over 10,000 square meters per hectare is equals to 0.005 kilograms per square meters. B. 0.005 kilograms per square meters times 3,500 square meters would be 17.5 kilograms of 1620. Next, how to determine the amounts of fertilizer needed to apply when the treatment or dosage is in ppm. Note that the 5 ppm, which means 5 milligrams per liter or 5 grams per cubic meters of water. For the problem, how much amount of 620 will be needed in a 1 hectare pond having a water depth of 1 meter and requiring a treatment or dosage of 5 ppm? For the solution, we have 10,000 square meters times 1 meter water depth multiplied to 5 grams over cubic meter. It is equals to 10,000 cubic meters times 5 grams over 1 cubic meter. The total would be 50,000 grams or 50 kilograms of 1620. Next, to find the dosage of fertilizer in ppm when the amount of fertilizer to be applied and the volume of water are given is to use the following formula. Dosage of application in ppm is equal to the amount of fertilizer to be applied in grams over the actual volume of water. The given R, amount of fertilizer to be applied in the whole area, is equal to 50 kilograms or 50,000 grams per hectare. The volume of water in a hectare of pond is equal to 10,000 cubic meters. The solution would be 50,000 grams over 10,000 cubic meters is equal to 5 grams over cubic meters or 5 ppm. Next, how to determine the equivalence of amount of inorganic fertilizer to animal manure basing on one of the NPK content, say P only or N only of the fertilizer. If 1 hectare pond would require 50 kilograms of inorganic fertilizer having a phosphorus content of 20%, how many kilograms of organic fertilizer containing 0.41% phosphorus would be needed as equivalents of the former fertilizer in terms of the phosphorus content? For the solution, the first step will be determining the amount of phosphorus in kilogram in the 50 kilograms of inorganic fertilizer like the 1620. Thus, it will equal to 50 kilograms times 0.2 phosphorus. The total would be 10 kilograms of phosphorus. Second step is to determine the amount of the animal manure in kilogram using an algebraic solution. Thus, 0.0041 P X is equal to 10 kilograms of P in 1620 fertilizer. In continuation, X is equal to 10 kg phosphorus over 0.0041 phosphorus, which has a total of 2439 kilograms or 2,400 kilograms of animal manure. To check the equivalent amount of phosphorus in animal manure is to do the following. 2,439 kilograms of manure multiplied to 0.0041 phosphorus is equal to 10 kilograms of phosphorus in manure. Next, how to determine the exact rate of organic manure fertilizer application with the consideration of the following. Number 1, organic matter of soil. 2, organic matter of manure, and 3, depth of surface soil that benefits from fertilization. The formula for AM is equal to B multiplied to C minus X over X minus D. AM is the amount of the animal manure of poultry, B, the weight of 2 centimeter depth of surface soil in an area to be fertilized. C. Original organic matter content of the subject pond soil. The D is the organic matter content of the poultry manure. The X would be the desired organic matter content of the subject pond soil. Given the following, B is equal to 200 tons, C 7%, D is 40%, and X is 8%. Substitute the given to the formula of the AM, which is equal to B multiplied to C minus X over X minus T. This will have 200 tons multiplied to 7% minus 8% over 8% minus 40%. Next, turn the percent form into a decimal form. We will have the 0.07 minus 0.08, which is equal to negative 0.01. Next, we have 0.08 minus 0.40, which is equal to negative 0.32. Next is to multiply the 200 tons to the negative 0.01, which is equal to negative 2. Copy the negative 0.32 and then divide them together. We will have a total of 6.25 tons per hectare.
Hello, I am Sittie Guiapar, and here are the common practice rate of fertilizer application. For chicken manure as an organic fertilizer, we use a 3,000 to 4,000 kg per hectare in combination with 50 kg per hectare urea for newly constructed pond on sandy loam pond as a basal fertilization. For old and loamy to clay ponds, we use 1,000 to 2,000 kg per hectare in combination with 50 kg per hectare urea as a basal fertilization. And for the maintenance of plankters or lab, 1,000 to 2,000 kg per hectare are applied every 2 weeks until 30 days before harvest. So when using inorganic fertilizer for salty water, we apply 15 kilograms of 16-20 or triple 14 as a basal fertilization. For maintenance, we have 8 kg of nitrogen and 10 kg of phosphorus per hectare, which is this is the equivalent to 50 kg per hectare of 16-20 fertilizer. This is to be applied every after 2 weeks until 2 weeks before harvest. What are the recommended methods when applying a fertilizer? Mix 1/3 to 1/2 of the total amount of fertilizer to be applied with water in a pail. The fertilizer in solution will then be applied evenly across the surface of the pond, and the remaining portion will be covered with cloth and hung from the stake or placed on a platform that has been installed beforehand in the pond to gradually dissolve. For do's and don'ts, applying it on overcast or rainy days or hours is not advised. Apply it between 9 a.m. and 12 p.m. on a sunny day to allow plant organisms to quickly assimilate. Also, it is not advisable to use organic fertilizers immediately. The organic fertilizer should be soaked first with a container bag. Propagation of lab fertilization. First, apply manure by spreading evenly over the pond bottom. Admit water to a depth of about 3 to 5 cm, then apply 50 kg per hectare urea, and then allow the pond to dry. Third, readmit water to average depth of 8 to 10 cm. Apply 16-20 fertilizer at 100 gram per hectare or 18-46-0 at a 50 kg per hectare. Admit an additional 5 cm depth of water every 3 days until it reaches the 20 cm level. Apply 16-20 at 15 kg per hectare every 7 days but not less than 3 days before stocking of fish. And then gradually drain 25% of water and refill it to the desired level. Lastly, apply a side dressing of 15 kg per hectare of 16-20 every 2 weeks. The production of plankton. Fill the pond with water to a depth of at least 60 cm, preferably 75 to 100 cm. Apply 1 to 2 tons per hectare of chicken manure contained in bags, and apply 16-20 of 50 kg per hectare or 22 kg per hectare of 1846-0 1 week after the first fertilization application. Observe the productivity of plankton for the next 7 days. Fish stocking shall be done 2 weeks or so after filling of water. Lastly, apply 50 kg per hectare of 1620 or 20 kg per hectare of 1846-0 every 2 weeks plus 1000 kg per hectare chicken manure every month thereafter to maintain the abundance of plankton. Lastly, for the growing of lumot, lumot or filamentous algae grows favorably in lower salinities and a water depth of 20 to 60 cm. It occurs naturally, but seeding may be resorted to when growth is sparse. The fibrous or silky filaments are best type of life stage of lumot for seeding or planting purposes. These are planted either by staking, sowing, or spreading. And that concludes the lecture for today. Thank you for watching.